Dear students, we are in the sixth part of the wrist and hand complex. So, continuing from the fifth part, so most of the investigators have found that flexion and extension of the radiocarpal joint occurs almost exclusively as flexion and extension, respectively, of the proximal carpal row. So, whenever there is a flexion extension of the radiocarpal joint occurs, the flexion may exclusively occur at the proximal carpal row, whereas others found simultaneous but lesser amount of radial bar ulnar deviation. So investigators found that whenever there is a flexion extension of the wrist joint happening, radiocarpal joints are happening, there is flexion of the proximal carpal row is happening. But some find that there may be radial and ulnar deviation, and also some are finding a mild degree of pronation and supination of the forearm, also of the three proximal pronation and supination of the uh, two or three proximal carpal bones are happening. So this is just to keep in mind that these things are also happening. Flexion and extension of the wrist joint. So during flexion extension of the wrist, the scaphoid seems to show the greatest motion of the three carp, whereas the lunate moves least. Uh, so already we have gone through this. Now we'll go to the next area. Motion of the more tightly bound distal carpals and their attached metacarpals during mid-carpal. See here, there's a repetition here. Don't write for notes here. We just after the previous slide come here. Okay, there is a mistake here. Like it has been repeated here. That's not a mistake. That's a repetition. Okay. Motion of the more tightly bound distal carpals and their attached metacarpals during mid-carpal flexion bar extension appears to be fairly simple corresponding flexion and extension. Mid-carpal bones, the motions are comparatively simple corresponding to flexion and extension, with movement of the distal segments proportional to the movements of the hand. So this is what we are trying to understand is whenever we see here the wrist is in flexion. So the extension motion of the wrist starts from the wrist being in full flexion. Here you can see the radius and the ulna, and then you can see the carpal bones. Here you can see the metacarpal bones. So here you can see that how in flexion position, see where the scaphoid is and see where the lunate is. See where the capitate is. See the capitate very the what we call as a keystone. So important bones in the distal carpal row, it is a capitate. In the proximal, the lunate and the scaphoid, very important. And you can see that the scaphoid is almost like collapsed. In flexion, it is collapsed and coming this area, whereas the lunate has moved towards upward. But scaphoid, see, it is trying to move to the upward, collapse and move to the upward position. And then you can see the capitate also trying to move in this direction. But while see now from this position going to the extension of the wrist, see the metacarpals are upward extension. So radius and extension here in the picture B. Here see where is the lunate is. Lunate which was in the upper part came to the downward. Scaphoid which was in the downward part started moving to upward and reached to the almost to the distal area. This scaphoid here has almost reached this to this level, almost in the level of radius. Before the scaphoid was below the level of radius. Now it is in the same level of radius. Lunate which was in the upper segment of the radius, see it is in the upper area of the radius, came to the almost to the middle of the radius. Now see the capitate which was below the level of radius, here it is below the level of radius. Now it is in the upward part because it is moving along with the metacarpal bones. So there are difference in movements. So during flexion, In flexion they are coming down, but from flexion to extension they start moving to the opposite direction. So the wrist extension, as the wrist extension is initiated from full flexion, the distal carpal row moves on the proximal carpal row. The distal carpal row, which is the capitate, including the capitate, hamate, and all, no, trapezium, trapezoid, they start moving. They start moving on whom? The proximal row. These will start move on the, these bones are moving on the proximal row. They will move upward. They are moving upward along, but mild movement of the lunate is also happening. Scaffold is moving the maximum, but see, scaffold from here it moved till here. Large movement is happening. That is what. So here it is already reached to this movement. Here the red arrow mark is showing the how they are moving. Uh, so the distal carpal row moves on the proximal carpal row. The scaphoid and the distal row move on the lunate and the trachutrum. The carpal move as a unit on the radius and the TFCC to achieve full wrist extension. Capitate. So here the C is capitate, L is lunate. I already told you that C is capitate, L is lunate, S is the scaphoid. Now we'll go through the motion. So we have divided the motions of flexion extension motion. Flexion extension, why I am saying flexion extension? Because when we are saying extension, it should either vice versa. Either the extension will start from full flexion to extension, then from full, if you are talking about flexion, it will start from full extension to flexion. So flexion extension vice versa is the total motion, divided into three parts. First part, the motion. Here we're talking about flexion action under the heading flexion action. Flexion. The motion begins with the wrist in full flexion. Active extension is initiated at the distal carpal row. We already understood that distal carpal row will move on the proximal. So active extension is initiated where it is initiating. Initiating means starting at the distal carpal row and at the firmly attached metacarpals by the wrist extensor muscle. The wrist extensor muscles are attached to the metacarpals and the phalanges. So this muscle will contract and the extension will begin, but the initiation of the bony mechanism, the biomechanical mechanism inside the wrist joint, initiates at the distal carpal rows to those bones. The distal carpals, already you know, no need to repeat again. Trapezium, trapezoid, capitate, and haminate. Capitate is called as a keystone. Glide on the relatively fixed proximal bones, which are there three. We are not mentioning pisiform, scaphoid, lunate, and trachutrum. Although the surface configurations of the mid-carpal joint are complex, the distal carpal row effectively glides in the same direction as the hand. They will move in the same direction as the hand. That is what we are understanding. When the wrist complex reaches neutral, that is when they are reaching to a neutral level, when they are reaching to the neutral level, that is a long axis. Neutral level means long axis of the third metacarpal in line with the long axis of the forearm. The ligaments, that means that basically the metacarpals and the forearm are in the same level. So we are taking the third metacarpal, which is almost in the as a middle part, middle metacarpal. So that will, if it is straight to the radius and ulna, then we can, that is the forearm, we can call it as a neutral. Wrist is in neutral. The ligaments spanning the capitate and scaphoid draw. Capitate and scaphoid means they are both. Scaphoid belongs to proximal and capitate belongs to the distal. Both are very important in each row. Draw the capitate and scaphoid together into a closed pack position. This position, you already know what is a closed pack position. There is no free movement possible. So these bones, capitate and scaphoid, which are part of the scaphoid part of the proximal row, carpal row, capitate part of the distal carpal row, When in neutral position, what is a neutral position? Long axis of the third metacarpal in line with the long axis of the forearm. This will is create the ligaments which will go into passive ligamentous tension, will create what we call as close packed position. In the second part of the motion, continued extensor force. Now we started from the complete flexion, we reached almost to the neutral. You understood, no? The initiation is happening in the distal carpal row. The extensor muscles are attached and they are pulling the metacarpals. Now we have reached the neutral. Then again now we are going to the high extension. Continued extensor force now moves a combined unit of the distal carpal row. Now after neutral again it will be going more now towards extensor area. Level will be above. The wrist, the hand will go to above the level of if you are putting your hand and forearm on a table and then try to lift your hand, only the hand, so that kind of movement is happening now. So this here continued extensor force now moves the combined unit of the distal carpal row and the scaphoid on the relatively fixed lunate and tricutum. At approximately of an extension of the wrist complex, the scapholunate introitious ligament brings the scaphoid and lunate into close pack position. Earlier we saw the ligaments which were attached between the scaphoid and the capitate in the neutral position coming into close pack position. Now again further moving from that position to extension, now we are seeing the scapholunate, that is a ligament between the proximal bones scaphoid and lunate into close pack position. This unites all the carpals and causes them to function as a single unit. Only then we will have a very good strong, some resistance will be there, so then only one can function efficiently with their hand. Completion of wrist complex extension, then now reaching to the final range of extension. That's what we mean by completion. Completion of wrist complex extension occurs as the proximal articular surface of the carpals move as a solid unit on the radius and the TFC. The final movement is the proximal carpals, all the carpal bones, which are the scaphoid, lunate, and trochlear, they act as a single unit, not as a different bones. Single unit, and they move over the radius and the TFCC, triangular fibrocartilaginous complex. That movement will give the final completion of the wrist extension. All ligaments, just try with your hand now when I'm telling this, try full extension. After that, when you reach full extension, you feel some kind of tightness. The muscles are tight and the ligaments are tight. There is a fully closed pack. This is called as fully closed pack position in the wrist joint. Okay, and this is the full flexion extension motion. If you take the opposite, that is a reverse motion sequence, is called as extension to flexion. There is nothing more to talk about here because extension flexion exactly opposite things will happen, but in the opposite direction. Earlier we talked about the three positions of the one, two, three motions of the one is in flexion to neutral. Then in neutral what is happening? Then from neutral to extension what is happening, and then completion. I hope you understood. It is very, very important because this moment, this stability of the wrist joint, and this intercalated segment, and the how the carpal bones are acting as a single unit in the final extension, how they are acting in the as a close packed position where where the capitate and the scaphoid are acting as a single unit in the neutral is very, very important. Then only if the wrist is strong, only then we can use our fingers very well. If our wrist is not strong, we cannot use, even though if your muscles of the flexor tendons, all the the flexor carpi ulnaris, or even the FDP, the flexor digitorum profunda, the FDS, flexor digitorum superficialis, all those are long flexor good muscles, they give stability, make our hand more functionable. We will study about that later, but for that what we need is a very stable wrist joint. So this is the wrist motion have discussed. So one would expect extension of the hand to be accompanied by sliding of the convex proximal carpal surface volarly in a direction